Next, proof number 40. Prove that integral 1 by 1 minus x square into dx is equal to 1 by 2 log modulus of 1 plus x by 1 minus x plus c. Okay. So here concept is indefinite integration. So we have to prove integral of this function 1 by 1 minus x square with dx with respect to x is equal to of log modulus of 1 plus x by 1 minus x plus c. 1 plus x by 1 minus x plus c. So anyhow, here function is f of x is equal to, given function is 1 by 1 minus x square. And remember, there is no direct methodology to find integration of this function. Okay. So here I am going to use partial fractions. Okay. So partial fraction use chesi nenu prove chestanu. So see, here 1 by 1 minus x square. Observe denominator. Here denominator is 1 minus x square. So it can be written as 1 square minus x square. Okay. So we have an identity a square minus b square. So a square minus b square is equal to what? A plus b into a minus b. Very important identity. So now f of x is equals to 1 by a square minus b square, a plus b into a minus b, a plus b into a minus b. Okay. Still we cannot integrate this function directly. Okay, no? We cannot prove directly 1 by 1 plus x into 1 minus x is equals to this. So apply partial fractions. So now apply partial fractions. Next concept, partial fractions. So this is proper fraction because degree of numerator is 0 because 1 is a constant polynomial. Degree of denominator x into x, x square. So highest power of the variable is 2. So okay na. So numerator degree is 0, denominator degree is 2. So if degree of numerator polynomial is less than degree of denominator polynomial, then that fraction is called improper fraction. Okay na? Sorry, that fraction is called proper fraction, not improper fraction, proper fraction. Okay. So if degree of numerator is more than degree of denominator, then it is called improper fraction. Okay. So this is proper fraction. Now, so in case of proper fraction, now observe denominator. Here denominator contains non-repeated linear factors, linear polynomials. Linear factors or linear polynomials. See, this is linear polynomial because highest power of the variable is 1. This is also linear polynomial because highest power of the variable is 1. So denominator contains two non-repeated linear polynomials. Repeat avadam ledadu. Okay. So 1 plus x oksari ochindi, 1 minus x kuda oksari ochindi. Okay. So what is the general form of for partial fractions when denominator contains non-repeated linear factors? So a by constant by first linear factor 1 plus x plus b by 1 minus x. Okay na? So general form or standard form of this proper fraction is a by 1 plus x plus b by 1 minus x. Here we need a and b. Here we need a and b. So here a and b are constants. Let us find constants. So 1 by 1 plus x into 1 minus x is equal to. So what is the LCM? LCM is 1 plus x into 1 minus x. Next, cross multiplication. A into 1 minus x. Now b into 1 plus x plus b into 1 plus x plus b into 1 plus x. So denominator get cancelled. 1 is equal to a into 1 minus x plus b into 1 plus x. Let us simplify further. A into 1a, a into minus x, ax plus b into 1b, b into x plus bx. Okay, b into x, bx. So to find a and b, compare compare coefficients of x on both sides. Compare coefficients of x on both sides. Here there is no x term, so 0 is equal to, here what is coefficient of x? Minus a. Here coefficient of x is b, minus a plus b is equal to 0. So by comparing coefficients of x, we have got this equation. So let us name it as 1, equation number 1. Now next, compare constants. Now compare constants on both sides. So in LHS side we have constant 1, and in RHS a and we have plus b. Okay na? So by comparing constant we have got one more equation. Okay na? Let us name it as 2, equation number 2. Now using equation number 1 and equation number 2 we can find the constants a and b. See, observe equation 1 and equation 2. When we add equation 1 and equation 2, here negative a, positive a get cancelled, we can find b value. So by adding equation 1 and equation 2, 1 plus 2. By adding equation 1 and equation 2, minus a plus b is equal to 0, a plus b is equal to 1. So minus a plus a get cancelled, b plus b, 2b. So 2b is equal to 0 plus 1. Now b is equal to transpose 2. You will get 1 by 2. So by comparing coefficients, we have got two equations. Equation number 1, minus a plus b is equal to 0, and equation 2, a plus b is equal to 1. Okay. So by adding equation 1 and equation 2, we can find b value, because here negative a, positive a get cancelled, b plus b, 2b is equal to 0 plus 1, 1. Now b is equal to transpose 2. You will get 1 by 2. Okay. So b is equal to 1 by 2. Now how to find a value? Use either equation 1 or equation 2. In equation 1, minus a plus b is equal to 0. Now transpose minus a, you will get plus a. B is equal to, negative a becomes positive a. B is equal to what? 1 by 2. Therefore a is also equal to 1 by 2. So therefore 1 by x plus 1 plus x into 1 minus x is equal to a by 1 plus x. A value 1 by 2. So 1 by 2 by 1 plus x plus b by, so 1 by 2 by 1 minus x. Okay. So at last, partial fractions of 1 by 1 minus x square is equal to 1 by 2 of 1 by 1 plus x plus 1 by 1 minus x. Okay na? So we can write 1 by 1 minus x square as 1 by 2 of 1 by 1 plus x plus 1 by 1 minus x. So 1 by 1 minus x square ni ila rayichu manam. Okay na? Now we are going to, it is possible to find integration of this function. Now process is very simple. See, now apply integration. Integral of, here 1 by 2 is constant. Take out constant out of the derivative. Now integral of 1 by 1 plus x plus 1 by 1 minus x into dx. Okay. So now distribute integration. Then 1 by 2 integral of 1 by 1 plus x dx plus integral of 1 by 1 minus x dx. Okay na? It's like a distributive property. Okay na? Integral f of x plus g of x of dx is equal to integral f of x into dx plus integral g of x into dx. Okay, like distributive property ఎలా అప్లై చేస్తాం, అలాగే ఇంటిగ్రేషన్ ని డిస్ట్రిబ్యూట్ చేయాలి ఈ టూ ఫంక్షన్స్ కి. నౌ see integral 1 by 1 plus x dx, integral 1 by 1 plus x dx. So we need to find integral of this function and this function. First, let us consider this function. So first, this is part 1 and this is part 2. Okay, na? Let us find integration in 2 parts. So 2 parts can find out chestan. Okay, na? So part 1, let us find integration of 1 by 1 plus x. So here part 1 is integral of 1 by 1 plus x dx. So here I am going to use substitution method. Okay. So because substitution method is very simple. Here denominator is 1 plus x. Let 1 plus x is equals to some t1. 1 plus x is equals to some t1, variable t1. Now apply derivative on both sides with respect to x. Apply derivative on both sides with respect to x. See, d by dx of 1 plus x is equal to d by dx of t1. Apply derivative on both sides with respect to x. Now distribute d by dx, derivative. So d by dx of 1 plus d by dx of x is equal to dt1 by dx. So derivative of constant 0, derivative of x, dx by dx means 1 is equal to dt1 by dx. Now transpose dx, you will get dx is equals to dt1, dx is equals to dt1. So 1 plus x is equal to t1, dx is equal to dt1. Okay, na? So in place of 1 plus x we can take t1 here, and in place of dx we can take dt1. Then find integral. Okay, na? Okay. So now integral of 1 by 1 plus x is equals to, we consider t1, and dx is equal to dt1. Now integral of 1 by t1 into dt1 is equal to what? Log t1 plus some constant c1. Okay, na? So whenever we apply integration we get some constant. Here this constant is known as integrating constant or constant of integration. So log of, so t1, what is the actual expression for t1? t1 is equal to 1 plus x. Replace t1 by 1 plus x. So log of 1 plus x plus c1. Therefore integral of 1 by 1 plus x dx. So value of this function, integral of this function is log of 1 plus x plus c1. Let us find integral of this function. Now part 2. Part 1 completed. Part 2. Integral of 1 by 1 minus x dx. Same procedure, using substitution method. Again put 1 minus x is equals to some t2. We already used t1. So now let us use t2. Now again apply differentiation on both sides with respect to, or derivative on both sides with respect to x. d by dx of 1 minus x, d by dx of t2. So now apply distributive property, d by dx of 1 minus d by dx of x is equal to dt2 by dx. So d by dx of 1 0, dx by dx 1. You will get minus 0 minus 1 minus 1 dt. Okay, now minus 1 is equal to dt2 by dx. d by dx of 1 constant 0 minus dx by dx 1 minus 1 is equal to dt2 by dx. Now transpose dx. Here 0 minus 1 minus 1. Minus 1 into dx. Minus dx is equal to dt. Okay, na? Now multiply both sides of this equation by minus 1. So I just want to make dx positive. So minus into minus plus, plus into minus minus. So my dx is equals to minus dt. Now integral of 1 by 1 minus x dx is equal to integral of 1 by 1 minus x is equal to what? t2. 1 minus x is equals to t2 into dx. Dx value minus dt. It will be minus integral dt2 by t2. dt2 by t2 what? So dt2 by integral of dx by x, log x, like minus integral dt2 by t2 log t2. Minus log t2 is equal to what? t2 is equal to 1 minus x. Okay, na? Whenever we apply integration, you will get some constant. Let it be constant C2 plus C2. Therefore, integral of 1 by 1 minus x dx is equal to minus log 1 minus x plus some constant C2. Okay. Now combine part 1 and part 2. We have part 1 and part 2. Now what is 1 by 2? Integral of 1 by 1 plus x dx is log 1 plus x plus c1 plus minus part 2 minus log 1 minus x plus c2. Okay, na? Now combine part 1 and part 2. Now log a minus log b. It's like log a minus log b. Log a by b of log a by b. A value 1 plus x by b value 1 minus x. B value 1 minus plus c1 plus c2 plus c1 constants plus c2. Okay, now distribute 1 by 2. 1 by 2 of log 1 plus x by 1 minus x plus 1 by 2 of c1 plus c2. Let us assume here 1 by 2 c1 plus 1 by 2 is a constant, c1 constant, c2 constant. Okay, na? Let us assume this entire expression is equal to some capital C. Okay, na? Therefore integral 1 by 1 minus x square dx is equal to half of log modulus. So we know that logarithm of negative numbers or negative expression not defined. Keep modulus and modulus of log modulus of 1 plus x by 1 minus x plus capital C, where capital C is equal to half of C1 plus C2. Therefore this is the formula for integral of 1 by 1 minus x square dx. Okay.